So I would like to use this opportunity to report to this group some of our recent development in our Center for Data Science and AI. I know a few colleagues have already seen this from different channels, but this is only a few minutes. I'm going to be very quick, and we finish on time. Don't delay opportunities, actually. And our center was established by the Minister Aisha Vero, the previous government, 2 years ago, actually. This is, and also from our government, and also there was the next person is Professor Yao Chujin, previously from Germany, and he was the IEEE Computational Intelligence Society president. So in the international AI community, Nick Smith is our vice chancellor. That's 2 years ago, and currently we have our center, the exec team, actually. Many people probably know Steve and Ivy and Bing and Richard. Bing is here. And then there's some other professors and fellows, and we have 2 fellows of Rural Society, 4 fellows of IEEE, and also 5 fellows for New Zealand. This is some other colleagues associated with our center, coming from different schools and faculties from the university, but mainly from previous engineering and computer science and mathematics and statistics. There are also some from commerce, from this building, and some from humanities and social sciences. Here is a random photo and university talk that 4 weeks ago, last month, we had a showcase day, and there were 10 screens, over 50 postdocs. We showed to the rest of our university, and some of our Wellington industry, and some colleagues are already here today. So, our center has a vision, actually, to develop advanced fundamental research, innovative methods and techniques for key applications in New Zealand, particularly for primary industry, climate change, and medical health, and biotech, and high-value manufacturing, and also, the society's ethics and public policies to generate impact to economy and environment, health outcome, and social aspect. I fully understand our current government's stress on the economy side. And another task is actually also we train staff, early careers, and postdocs and PhD students. Actually, that's something we mentioned and previously. That we have, and originally I thought we have over 60 when I presented this in Christchurch, but 4 weeks ago I counted that's 83 actually. That's something. And so we have some of the fundamental research in the inner circle. The applications is outside. So in the middle, that's training and service. And we are asked also doing some IP and commercialization that's like from fundamental research, applied research, end users, and IP commercialization, like a research pipeline. And of course, Vision Mataranga, that's also one of our major focuses. Those are actually the six fundamental research areas we call technology themes or research labs in those areas. Those areas have already had some international leadership or reputation there. And the first one is modeling and statistical learning. This area, we have done different kind of research from both statistical learning and also the evolution learning and genetic programming. There's a lot of could do actually for regression classification and clustering and other kind of decision-making stuff. And evolution Additionally, multi-objective learning and optimization. This is one of our strengths. You might have already found actually previous discussions actually from Beck and Fang and Yi actually. They all talk about evolution learning using different kind of genetic programming or other evolution optimization method. And another one is multi-objective. It can treat and multiple objectives or conflicting criteria simultaneously. And other methods in AI and machine learning can do this, but not as easy as this, not as natural as this. And another big area, which image and text and signals and language processing, and and many people are doing computer vision, image processing, text mining, natural language processing, and a lot of we put that together. There's a group of people are doing in these areas, and we have different kind of methods from across almost all machine learning areas. And we also do deep learning and transfer learning, deep neural networks, transformers, a lot of other things. These days, if anyone doesn't do anything there, probably they claim you don't do any AI research, right? So this is a very big area. And in the transfer learning domain adaptation, that's another big area. Basically, we don't need to learn models from scratch, from the beginning. We learn from one area. We can apply that area to some other area or similar, closely related areas, and just that kind of share knowledge. And in fact, these days, there are a lot of talk about large language models or lots of other things, so-called and primarily training from scratch, and then fine-tuning is a kind of transfer learning. But many active learning, a lot of areas of this actually. This also deep neural network, so many things, diffusion models, there's a lot of things. We are not claiming we are terrific in every area, but in automated design of deep neural networks, you don't need to manually design. And usually the automated design of neural networks much smaller than and manually designed, and also easier to be understandable. And the final and fundamental area we talk about interpretable and explainable AI and machine learning. There's a lot of research in this space, and feature learning, feature selection, feature construction, and it's one of the typical examples, but there's a lot of others. Those actually, 2 years ago, before we stand actually, we talk about that established center, we said those areas we have been doing there. But in recent couple of years, and generative AI is very popular. If we don't do anything, people also complain. So we established some relatively new areas in the recent 2 years. One is actually generative AI large language models, and we have about 10 people, and a little bit over 10 people are doing different large amount of models, transformers, diffusion, and all actually few short learning stuff actually. And this also people consider this is generative and AI multimodal learning, learning from different sources. That's in the image area. That's very, very, very popular. And like the previous, also often and related to those actually, and the generative AI. So that's a lot in different aspects. And this is not a new area, but previously we didn't treat this as a series of time series data, stream learning, and that's the lifelong learning, continual learning. I know colleagues Jill and Waikato and Albert also doing a lot in this area. Also, HR in our group actually has been doing a lot in this area. With statistics together, we get a lot of requests from the domain application areas. A final one is optimization decision making. Today I have some presentations doing that. A lot of different kind of things in different industries. This is actually a very serious problem. and including those actually different kinds of methods. So we added those to enhance our fundamental AI areas. The key applications I mentioned a bit actually. That's, we collaborate with different originally we called CRIs and now we called PROs. For primary industry, this is the biggest one. And climate change, with ARC, Antarctic Research Center, and Earth Science in New Zealand, is a lot. And medical bio, that's one. And security, energy, and high-value manufacturing. Actually, the Pre-Chi have a workshop on those, quite a few of those. And one area is social ethics, society, and public policies. And Ali Nutt and Andrew Linson in our center, they are leading that area. That's doing a lot, there's a lot of areas. We have been collaborating with those CRIs and PROs, that's a lot. Infrastructure, a little bit, a couple minutes on that. So grid computing tech and facilities. Our center and school has over 500 machines connected together like a grid of cloud. And the university also have a report, similar number actually people, our staff and colleagues can do that. And you can see that are very limited of GPU resources. GPU resources in terms of that, our school and center, we got about 100, a little bit over 100 modern GPU cards. But this is very small number compared with the big companies like Google, Amazon, and OpenAI. We can't compete with them. We have more, and nothing we have about 30, a little bit over 30. But recently, our center are collaborating with the USA and also our government. And we are trying to build a New Zealand infrastructure in Wellington. We try to have a couple of thousand GPU cards of that one. This is recently, actually, 2 months ago, when I presented this in Christchurch, we haven't got that yet. And that's some kind of recent grant we got in those areas. And mainly the teaching programs, we have an undergraduate AI major and data science major, and we also have postgraduate studies. That's all, and now, and gradually most other universities also have those programs. In summary, actually, basically we have a wide range of those fundamental research applied areas, and basically we are very willing to collaborate with all people here and also all people in the country and internationally. Really looking forward, actually, to collaborate with everyone. New Zealand is small. We need to do things collaboratively. I think that's all. I should stop here. Exactly, actually, 15 minutes. Thank you very much.